In this example, we will find the magnitude and the direction of each of the following vectors. The first one we will do is v is equal to 1 comma negative square root of 3 for the first and second component, and w is equal to negative 2 and 2 for its first and second component. The way that we're going to calculate magnitude, which I'll start with v here, the magnitude of the vector v, we evaluate the same way we did the modulus of a complex number, as well as the radius of a polar value. That's really what this is. The same thing as radius, which we typically use the Pythagorean theorem for that purpose. We will treat the first component similar to x, and we will treat the second component similar to y. So the square root of the first component squared plus the second component squared. This one's pretty nice. 1 squared is 1. The square root of 3 squared is just 3. Meaning our answer overall here for the magnitude is simply the square root of 4, which is 2. For the magnitude, we will typically refer to the magnitude as a positive and adjust the direction as necessary depending on where the vector is, which we should consider. Our vector here is 1 comma negative square root of 3. If I were to draw that vector in standard position, starting from the origin, this means we are going 1 horizontally and down square root of 3. So that would be 1 positive horizontally, down square root of 3 vertically, meaning we have a vector that would end up in quadrant 4. This is important as the most common way of creating the direction, which I'll say direction for the vector v, is to work with arctangent. In this case, instead of arctangent of y over x, or with complex numbers b over a, we will take arctangent of the second component over the first. So that would be negative square root of 3 over 1. Arctangent of negative square root of 3 over 1. Recall that arctangent is defined to give an angle measure that is between negative pi over 2 and pi over 2. And because we are looking for an angle measure that would represent a vector in quadrant 4, that means arctangent of negative square root of 3 over 1 would provide us with the correct calculation. I do not need to adjust the angle measure in any way. Thankfully as well, arctangent of negative square root of 3 over 1 is something that we can evaluate, as I should know where that is on the unit circle, where tangent is equal to the ratio negative square root of 3 over 1 in quadrant 4. That would happen at, depending on how you'd like to write it, but with arctangent, at negative pi over 3, or if you prefer, 5 pi over 3. In this question, there are no restrictions as to how we will write the direction angle. So we have our magnitude, we have our direction. It doesn't ask us to do so, but if we were to write this vector now in polar component form, we can write v now as 2 times cosine of negative pi over 3, as well as 2 times sine of negative pi over 3. This is also a good way if you would like to check your answer, as if you evaluate 2 cosine of negative pi over 3, that will give you a positive 1. And if you evaluate 2 times sine of negative pi over 3, that will evaluate to be negative square root of 3. So good way to check your results. Let's move on to w. For w, the magnitude for w, again, using the Pythagorean theorem here of the 2 components squared, negative 2 squared and 2 squared. Well, that's not going to be too bad. That's the square root of 4 plus 4, which is the square root of 8. If you would prefer to write that as the 2 square root of 2, that is also sufficient. For the direction of w, though, when trying to work with arctangent, again keep in mind where our vector is going to be, or where the terminal point of the vector is anyway. W has negative 2 for the x component and positive 2 for the y component, which means this is going to reference a vector from the starting position at the origin up into quadrant 2. If I were to just evaluate this using arctangent of the second component over the first, this would not give me the correct solution, as this is going to give me an angle measure between negative pi halves and pi halves, or more specifically, between negative pi halves and 0. An angle measure in quadrant 4. We want something in quadrant 2. So that means whatever arctangent of 2 over negative 2 results in, we would need to add pi to that, or subtract pi, in order to get to an angle measure in quadrant 2. Thankfully, we do not need to leave it like this because we can evaluate arctangent of 2 over negative 2. That is also the same thing as arctangent of negative 1. An arctangent of negative 1 in quadrant 4 would be negative pi over 4. And when you add pi to that, that will give you the quadrant 3 angle measure of 3 pi over 4. Giving us both our magnitude and direction angle for W. If we were to write W now in polar component form, we could write that as the square root of 8 cosine of 3 pi over 4, as well as the square root of 8 sine of 3 pi over 4, which again is a good way to check your answer. Whether you know the angle measure, like we did in these two cases of negative pi over 3 and 3 pi over 4, or if you do not, as you should at least be able to recognize whether the result will give you a positive or a negative, which can help at least establish if you are going to get the right kind of vector. For example, here, cosine of 3 pi over 4, even if I didn't know what that would equal, I know 3 pi fourths is in quadrant 2, which means I would expect a negative value from this for cosine, which aligns with what I know about the first component for W. Some ways that you can check your results once you find both the magnitude and the direction.